So we're going to start with negative exponents, which is something you saw in 7th grade. Anytime you have a negative exponent, you have to write that as a fraction, and then you have to flip the fraction. When you send a negative exponent to the denominator, it becomes positive. And you could also go the other way. If you have a negative exponent on the bottom, you could flip it to the top. Flipping it both ways makes an exponent go negative to positive. So, in summary, if you have a negative exponent, flip the fraction. All right, one other thing that you should have learned in 7th grade is when it refers to the 0th power. So for example, like x to the 0 power, that always equals 1. Anything to the 0 power equals 1. And so I'm sure in general you've been taught that before, but there's this question of why is that? Why do we flip these fractions? Why does this equal 1? And it's because exponents go on a pattern. So it starts, if we had like 2 cubed, 2 cubed we know is 2 times 2 times 2, which is 8. And similarly, if we had 2 squared, we know 2 squared is 4. And if we had 2 to the first power, we know that'd be 0. Or, not, just kidding, it's not 0, it's 2. Testing you. So if we look at this pattern here, we're dividing by 2 each time. So if we followed this pattern and divided by 2 again, I'm now at 2 to the 0th power, so 2 divided by 2 would be 1. And after exponent 0 would come a negative exponent, negative first power, and I would do the same thing, divided by 2, which is 1/2, 1 divided by 2. And I could go even a step further, 2 to the negative second, divided by 2 again, is 1/4. So I'm going to pause the video and I want you to try one with the base of 3. Go from 3 cubed down to 3 to the negative second power to see if you can see if this holds true with a different base. So your exponent pattern should have looked like this. We're dividing by the base of 3 this time, and same reasons get to the 0 power equals 1, and for the same reasons why we flip a negative exponent. So, moving on to the next slide. I have to slide over. There we go. So here's just some negative exponents for you to practice with. I'll do the first one with you, and then I'll let you try these 3. 5 to the negative second power. Well, at first I know that's got to be 1 over 5 squared. And 5 squared I know is 25, so this is 1/25. All right, I'll let you pause and try these other 3. So hopefully your answers match mine. 1 over 343, 1 over x cubed, and then just a cubed. So moving on to the next stuff. If you look on the back of your paper, now we're going to start dividing monomials. And before we fill in this blank, we're actually going to start with this second example. And I remember last year I said I was going to make this the first example, but clearly I did not do that. B to the 15th power. So we know that that is b times b 15 times. So here we go. We're going to write 15 b's on the top. 1, 2, 3, 4, 5, 6, 7, 8. If it's any consolation, it's harder with a mouse. 9, 10, 11, 12, 13, 14, 15. So that's my numerator. And my denominator is b to the 7th. So I'll need 7 b's on the bottom. So I have 15 b's up top and 7 on the bottom. And these are going to cancel out like 1 by 1. So those cancel out. B divided by b is 1. Another set of b's, that equals 1. B divided by b equals 1. So I'm going to be able to do this 7 times. And I'm left with 1, 2, 3, 4, 5, 6, 7, 8. My answer is b to the 8th. So thinking here, when dividing monomials, there should be a trick because we don't want to do this every time. And there is. The answer is you subtract the exponents. Because if you look there, b to the 15th divided by b to the 7th, 15 minus 7 is 8, b to the 8th. So luckily for you, you don't have to write this out every time, but I did want to show you one time to see why it is we're subtracting. So here's just our general rule. When we have a to the m divided by a to the nth, you would solve that by doing a to the m minus n. In that order. It's numerator minus denominator. In that order. That is important. So, as we look at this third example here, we'll start by subtracting my a's. I have a to the 5th, and we remember from the last unit when there is no exponent, it's a 1. So I've got 5 minus 1, that should be a to the 4th. And then I have b to the 8th divided by b to the 3rd. I should be able to do 8 minus 3, which is b5. And that's my answer. So it's similar to multiplying binomials, but now we're dividing them. I think this is a little bit easier than multiplying. So then let's go to the last section here. First, when I have numbers, my coefficients, you divide those like normal. You're going to want to subtract those, but you don't. 28 divided by 4 is 7. Next, I have A5 minus A3 for A2. Then I have B6 minus B5, which is just B. You do not have to put B1 there. And then C, there's nothing to subtract from C, so that C is also going to stay as a 1. And that's my exponents and coefficients divided. All right. Let's look at this next one together also. First, we'll start by dividing my coefficients. These I'm not going to be able to divide evenly, but I can leave it as a fraction. I can simplify it to be negative 1/7. And I'm going to extend this fraction bar because as I subtract things, there's going to be stuff up top. Now I have a denominator of 7. So A, I've got A negative 4 minus 2. Negative 4 minus 2 is negative 6. I have B7 and B7. 7 minus 7 is 0. So those are gone. Canceled. And then lastly, I have a C to the negative 5th, and that will just stay on the bottom because there's nothing to subtract up top. Now, if you remember from the previous part of this lesson, we can't have negative exponents. And the way we get rid of negative exponents is by flipping them. So I'm going to take this A to the negative 6 and move it to the bottom, while taking C negative 5 and putting it up top. So I should have negative 1. C positive 5 over 7 A positive 6. You may have a question of why I didn't flip negative 1 to the bottom. It's because negative 1's not an exponent. Negative 1's a coefficient, and it's okay if your coefficients are negative. We just can't have negative exponents. So I'm going to have you pause and just try the next one only, not the last one, just this third one. All right, so the first thing you'll do is divide coefficients like normal. 30 divided by 5 is 6. Next, I'm going to start subtracting exponents. I have negative 2, and that's a 1 there. So negative 2 minus 1 is h to the negative 3rd. And then I have k 14 minus negative 3. I'm going to write that out just in case you didn't catch that. 14 minus negative 3 is actually plus, so positive 17. And then I know I have a negative exponent, and the way to get rid of that is to flip it to the bottom. So 6 will stay up top. That's okay. K17 is going to stay up top because that's positive, and that's what we want. But we've got to send H3 to the bottom so it becomes positive. So there is my new monomial. Cool. So the last one here, I'm going to let you try it on your own after we talk about what's going on down here. Hopefully you remember from the last lesson, when I have a power raised to a power, I have to multiply first. So my top isn't going to change. That's going to stay p negative 4, q negative 3. But on the bottom, I've got 5 to the negative first. That's going to become p to the negative 5th. And then q squared to the negative first is going to become q to the negative 2nd. So hopefully you'll be able to pause and go from here. I'll let you try it. All right, so we'll do p negative 4 and p negative 5. Negative 4 minus negative 5, that's positive 1. If you need to write that down, we can. Negative 4 minus negative 5 plus. Negative 3 minus negative 2, that's going to become negative 1. So I've got p1, q negative 1. So I know this is going to have to go to the bottom because it's negative. And I'm not going to rewrite p with an exponent of positive 1 because you just know that. P to the first is the same as p. Just like when q comes down here, that's technically q to the first now, but I don't have to write that either. If you did write p1, q1, that's also technically right, but I'm not going to write it just because you don't need to. Just p over q. So if you're still confused, I would say go back and watch that. But what I'm going to have you do now is this activity. You may not finish this today, and that's okay. But there's a bunch of puzzle pieces. You cut them out. And so like this one, for example, I know I'm going to have to, 5 divided by 3 is already simplified. But I'm going to have to subtract these exponents. So this should be 5 and y to the first power over 3. And so what I'll do is I'll look for that answer somewhere. And I'm going to have you tape these together. That way, when you're done, if you run out of time, your answers will be taped. You don't have to worry about glue. The last page is if you need to show any work, and I only have the answer key, so sorry about that. Yeah, hope that makes sense.